Welcome to Unit 8. Unit 8, we begin to shift gears. We're going to go from just doing mathematical equations and expressions and understanding steps and processes, and we're going to apply all of that information into geometry. So geometry, I often find with sixth graders is easier because we have reviewed the mathematical steps and processes multiple times, but then with geometry, we're dealing specifically with shapes. And students that can see the shapes and manipulate the shapes often seem to prefer geometry over doing just basic mathematical equations and expressions. So as we get into this lesson, it says that our goal, our objective is that we can understand how a parallelogram can be decomposed into a rectangle so that we can find its area. Now, decomposed does not mean like we talk about in science where things are dead and decaying. It means that I can break it apart into its pieces and I can rearrange them to make a rectangle. And then if I can use a rectangle shape, then I know, hopefully, from previous years, how to find the area of a rectangle. Well, we're just going to be looking at a specific formula that we're going to use on pretty much all of these different math problems that we do when it comes to our introduction of geometry in sixth grade. So when we see the idea of a parallelogram, we have opposite sides are equal, and it is a four-sided shape, then we can talk about how many of these square tiles or these square cubes are going to be used to fill it up. So when I see this particular example with the empty parallelogram, they give us how we talk about it in words, but then we are shown in symbols, which we also refer to as a formula. It says the area of the parallelogram, the space inside, is the product. Once again, product means we're going to multiply. And we have two things that have to be labeled. That would be the base, and that's going to be at the bottom. And it's going to be the height, which is indicated by a right angle. Now, when I talk about the base times the height, find the area that's filling it up. Now, that might get a little confusing. Last year, you talked about length times width. It's honestly the same idea. However, length times width only works when there are 90-degree angles, also known as right angles. So if I had a rectangle or if I had a square, then in the corner, I know that that is going to be a 90-degree angle. A rectangle is indeed a parallelogram because the definition of a parallelogram is that it's four-sided and it has opposite sides that are equal. It's a special parallelogram because it has four sides, opposite sides are equals, and the corners are 90 degrees. If it was a square, it would be the four-sided, opposite sides are equal, the corners are 90 degrees, and all four sides are the same length. Rectangles and squares, then I could use length times width. We're saying the same thing when it comes to this parallelogram that's empty, right? Because when it came to the rectangles, we're filling it up. We want to know how much space is inside. When I look at this particular parallelogram, I use base times height because of that slanted side. I'm not going to use the slanted side anytime that I am doing the area of a shape because it's not straight up and down. It could be really long depending on how big that obtuse angle is. So I have to have a specific height that is marked by a right angle. So that's why we use base times height when it comes to slanted parallelograms. So base times height is going to fill up this parallelogram when I multiply them together. So once again, simply finding their product. So when I look at this example that they walk us through, right, then we know that we have this flag and it says that Romelia is painting a replica of the national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. So I don't want the area of the entire flag, and I wouldn't be able to find it because of the measurements that are given. So I need to find what I know is the measurements that's required for the area of the black strip. So I look at the base. Well, that, once again, that's going to be the bottom measurement, and that gives me 6 3/4 inches. And now its height. Well, once again, I need a right angle. And since it is this flag, which is a rectangle shape, then I know in the bottom right-hand corner or the bottom left-hand corner, I could indicate that it's a right angle. The height of the flag has to be the height of this parallelogram. So I can use or need to use the 30 inches for the height of this black area. And then in order to do it, I'm simply going to multiply. Notice that they have the 6 3/4 and the 30 set off in parentheses. Just a reminder that parentheses touching parentheses just simply mean multiplication. However, when I look at the math problem, I know I can't multiply mixed numbers and whole numbers. So I have to review that process. How do I change the 6 3/4 into something that I can use? Adding, I can use mixed numbers. Subtracting, I can use mixed numbers. However, multiplying and dividing, I can't. So I have to make it an improper fraction. That process, once again, is I'm always going to start at the bottom. So I start at the denominator, and I'm going to go clockwise. So 4 times 6, because my first step is to multiply. I start at the bottom, I multiply. That gives me 24. And then I add. So I take the 24, and I add it to the numerator, 24 times 3. That's going to give me a numerator of 27. My denominator of 4, it simply stays the same. Now I have an improper fraction, and I can put that into the math problem. So where it says multiply, I'm going to have the 27 on top, the 4 on the bottom, and I'm going to multiply it by the 30. Well, if I can't multiply by mixed numbers, I also can't multiply by whole numbers. So that's the easy one. What do I do with the whole number? I simply put it over 1. So if I multiply straight across, right? So the questions are, can I multiply fractions? Yes. How? I multiply across. If I multiply straight across, I pick out my handy dandy calculator, I type in 27 times 30 or 30 times 27 because they can be done in either way. And then I do 4 times 1. Well, 4 times 1 is the easy one, that is 4. When I type in 27 times 30, that's 810. Now, not only is that top heavy, but I can also see that that's 2 even numbers. So I know I'm going to have to reduce at some point. But since it's top heavy, I like to just simply do the division first. Once again, fraction is always division, and it's the top number that always goes inside the box. It doesn't matter about its size. I divide by 4, so 4 will go into 8 2 times, because 2 times 4 is 8. I bring down my 1, 4 won't go into 1, but if something comes down, I have to put something up. So I ask, how many times will 4 go into 1? And that is 0. Well, then I'm going to bring down my 0, and how many times will 4 go into 10? And that is 2. Well, 2 times 4 is 8, which gives me a remainder of 2. Since I started with a fraction in my first number, I'm going to end with a fraction as well. So keep in mind how we create that remainder as a fraction. My remainder itself is my numerator, always and forever. So that's a 2. And my denominator stays the same, or my divisor, the one on the outside, is going to be my denominator. But then when I notice my fraction, they're both even. So that's where I'm going to have to reduce. And since they're both even, I know 2 will go into both of them. Reducing, once again, simply means to divide the top and bottom by the exact same number. 2 will go into 2 once, and 2 will go into 4 twice. So I end up with an answer of 202 1/2. Now I want to pause for just a moment and review how we cross-reduce. And some of you prefer to cross-reduce, and some of you simply prefer to multiply across and then reduce. Either way, we should end up with the same answer. But just a quick review on how we cross-reduce. If I notice that the 4 in the denominator and the 30 in the numerator are indeed even, then I could tell myself, well, I wonder if 4 will go into 30. Well, it won't evenly. Therefore, if I reduce by 2's now, so I'm going to cross-reduce by 2's, and 2 will go into 4, as well as 2 go into 30. 2 goes into 4 2 times, and 2 goes into 30 15 times. Then, when I multiply across to find my answers, I'm just dealing with smaller numbers. So when I multiply across and I get 27 times 15, this time I'm going to get a different number. And then my 2 times my 1 gives me a different number. Well, 2 times 1 is 2, and 27 times 15 is 405. So it's just a little smaller numbers that I can do my math with. My next step would be the same. I'm going to take my numerator, the 405, divided by my denominator of 2, and 2 goes into 4 2 times. When I bring down the 0, right, then 2 won't go into 0, so it goes in 0 times. I bring down my 5, and 2 goes into 5 how many times? Well, that's 2, which is 4, and I have a remainder of 1. My remainder is my numerator, and my 2, my denominator, stays the same. Notice I end up with the same answer that I had before, and that was the goal. But I can cross-reduce to work with smaller numbers. Just keep in mind you don't have to. I'm just reviewing on how that process works. All right, now before we go on, then we have to look at specifically what kind of labels we have when it comes to area. Always and forever, we have to have a specific label when it comes to area. Notice that what I'm multiplying together are two measurements. So we end up with looking at the labels and we're saying, well, we're multiplying inches by inches. Well, I really can't multiply inches by inches, right? So what we end up with is inches squared. In the same way that if I took 3 squared, that would be mathematically 3 times 3. Well, since I can't really change inches and inches into numbers, I'm just simply going to square it, or as the book will often show, we just write square inches. We can abbreviate it as SQIN either way. But the answer has to have the label, and the label has to be squared when I'm finding the area. All right, so let's look at the check problem where we have a parking space. I want you to know how much area is in that parking space. So how much would it take to fill up that particular parallelogram? So they give us our two measurements that we need. We can see that our base is 9 1/4 feet and our height is 18 feet. Now I know that I have base times height is going to give me my area, but I can't multiply mixed numbers and whole numbers. So once again, I have to make it into an improper fraction by going clockwise, starting at the bottom and multiply and add. So 4 times 9 is going to give me my 36. Plus, I'm going to add my 36 plus 1. It gives me my numerator of 37. My denominator of 4, it simply stays the same. So now I have 37/4 that I can multiply by my height, which is 18. But once again, I can't multiply fractions and whole numbers, so I have to make that a fraction by simply putting it in over 1. I personally like to cross-reduce. If you want to multiply straight across now, you may, but I'm going to cross-reduce so I can work with smaller numbers. I can see that 4 and 18 are even numbers, and that 4 will not go into 18 evenly. So I'm going to reduce both of those by 2. So if I divide the 4 and the 18 by 2, 2 is going to go into 4 2 times, and 2 will go into 18 9 times. How do I multiply fractions? Well, I simply, once again, multiply across. So now I can pick up my handy dandy calculator and multiply 37 times 9. That's going to give me 333, and 2 times 1 gives me 2. Improper fractions now are always division. Any fraction is division. So I take my top number, put it inside my box, divide by my bottom number or my denominator. So I divide by 2. 2 goes into 3 one time because 1 times 2 is 2. I have a remainder of 1. I'm going to bring down my 3, and 2 will go into 13 6 times because 6 times 2 is 12 with a remainder of 1. Bring down my next 3, and 2 will go into 13 6 times because 6 times 2 is 12. I have a remainder of 1. I have nothing else to bring down. I started with fractions. I'm going to end with fractions. Therefore, my remainder, once again, is going to be my numerator, and my divisor, my denominator, is going to stay the same. So I end up with an answer of 166 1/2. But I have to remember that I'm doing area and I have to have a label and a very specific label. So I have to have square feet. Okay, so hopefully we're good there. But then we have to see that in the next set of examples, they're not going to give us one of our measurements. So if I have an example like this in example 2, where I'm not given one of my measurements, then I have to pause for a moment and look at what I am given because I'm given an answer, right? So if I know that base times height has to be equal to my area, and it's 9 times h is equal to 45, then we have to remember our fact families for multiplication and division, right? So I know, once again, doing my fact families, if we look at how those problems are set up, if I'm given multiplication with a variable, I'm going to divide the answer by the given number to end up with what the variable is. So in this scenario, instead of having 9 times 8 is equal to 45, I'm going to take the area of 45 and divide it by the 9, the base that I'm given, in order to find my height. So when I do that math and I take 45 divided by 9, I can see that that's an even 5, because 5 times 9 is 45 and I have a 0 remainder. So what we're finding now is that we have an answer or a height of 5. Notice the label they give you there. It's just inches, right? So if I'm finding one of the missing measurements, I have to have straight units. I can't have squared units. I'm only going to have a squared unit if it's going to be the answer, such as is circled on the example there. So as we look at this check, we can see it's very similar to the example 2 that they give us. Right? We've given some information. The only difference is they've turned it on their side and switched which one of the measurements they give us. That's okay. It's still done the same way, right? So if I have my B and I have my H, which is my height, I know once again it's my height because it's indicated with the straight line and the 90-degree angle, but then they give me my answer. That's all right. If we have B times 8 is equal to 96, then I know my fact family is a multiplication and division. I take my answer, I divide it by the number that's given to find my missing number. We can do that. So we take 96, top number goes inside the box, divided by the 8, and 8 will go into 9 one time, because 1 times 8 is 8. Gives me a remainder of 1. I bring down my 6. 8 goes into 16 2 times, because 2 times 8 is 16. I have a 0 remainder, which tells me that my base is equal to 12. Once again, since I'm finding a measurement, then I'm going to have the straight unit, and that's going to be 12 yards. So let's look at the type problems they give us where it becomes a little bit more complicated, right? So it says that Margie is designing a collage that will be shaped like a parallelogram as shown. The center of the collage will be a square photo that has an area of 0.25 square foot. This will be surrounded by painted square tiles that each have an area of 0.0625 square foot. How many whole tiles does Margie need to cover the collage? That's a whole lot of information, right? That's why we cube it. Right? We're going to circle the numbers in the units. We're going to box in clue words. We're going to underline our question. We're going to evaluate what it is we need to do and eliminate any information we don't need. And then we're going to solve for the answer. So when I start out and I'm reading and I see the word parallelogram, I have to have in mind what we're talking about. Right? So once again, it's a four-sided shape with opposite sides that are equal. We're talking about area, so therefore I now have to use that formula of base times height. All right, so then it tells me that the area is 0.25 square foot for the square photo that's in the center. All right, that's going to be important. And that we have an area of 0.0625 square foot for each of the other tiles that are surrounding it. Okay. And it wants to know how many whole tiles does Margie need to cover the collage. So we're looking at that light blue area that's going to be covered. Covered with what? 0.0625 square foot, right? And that's going to be each of those tiles. And so therefore, what does each mean? In this case, each means division. And now some of you are like, whoa, hold on, Mr. Barker. You had said before, like in Unit 6, that each means multiplication. And what I want you to know is what I said was, according to the problem that we were talking about, it meant that we were going to multiply because we had to find the whole. And I said that each can mean multiplication or division depending on how it's being used in a math problem. When I look at this particular math problem, then what it's saying is I'm going to use that and I'm going to break up the whole into those parts. So if each is used to indicate parts of a whole, then I need to divide. Only will I multiply if I'm using each to find the whole. So we have to know and understand what it is the problem is telling us. And then some of you think that's a whole lot of information to remember. And I say, I agree. There is a lot to remember in math. But that is why I make the videos and I allow you to use my PowerPoints, and you can go back and review them at any time you need to. They're going to be on YouTube until YouTube disappears or I'm gone and someone takes it down. So even next year, if you need to review some of these things, it's there for you. Feel free to review it at any time you need to. So if I know the information in the problem, now I need to locate the information that I'm going to be doing. So now I evaluate the process that I need to do. I know I need to find the area of the blue parallelogram. But then they tell me, well, that little white square, that's got to be taken out, right? Because that's not going to be covered by the blue tiles. It's going to be where a photo is. So I then will subtract that area, the 0.25, the 25 hundredths of a square foot, from the area that I get for the parallelogram. And then they say, well, I need to know how many tiles I'm going to need that are 0.0625 or 625 ten-thousandths of a square foot that are blue to cover the rest of the area. So then I'm going to divide what's left by 0.0625. All right, so I know the numbers I'm going to use, right? Because I know it's base times height. I have a height of 3.19. I have a base of 3.6. I'm good to go there. But the E on cubes tells me to eliminate any non-important information. Get rid of that slanted angle. We don't need it. It is truly there simply to confuse you. You won't use it at all in the math problem. So I'm left with base times height, 3.6 times 3.19. And therefore, when I stack it, I have decimals, multiple digits. So I know I'm going to start by multiplying with a 6. All right, so 6 times 9 is going to be 54. So I put down my 4, carry my addition of 5. 6 times 1 is 6 plus 5. Well, that's 11. So I put down my 1 and carry my 1. 6 times 3 is 18 plus 1 is 19. So that's what I'm left with. My second number, I underline it, tells me to, I circle what's behind it, bring down a 0. So I hold that place value before I do my multiplication with my second number. Now I have 3 times 9. Well, 3 times 9 is 27. I put down my 7, carry my addition of 2. 3 times 1 is 3, plus 2 is 5. And 3 times 3 is 9. So now I know I have my numbers. I add those together. I have 4 and 0, which is 4, 1 and 7, which is 8, 9 and 5 is 14, carry my 1, 9 plus 1 plus 1, that gives me 11. I multiply decimals, so now I count my decimal spaces. Once again, it's not how many decimal points, but how many spaces there are in my math problem behind the decimal points. And in this one, I have 3. So I have to move my decimal point from right to left 3 times. That's required. That gives me 11.484. That's step 1. We found the area of the parallelogram. But now I have to subtract the area of the picture. And when I subtract decimals, I line up my decimals. So if I line up, I'm going to take 0.25 away, and I see that I have an empty space there underneath that far right 4. So I have to add a 0. Once I line up my decimals and I fill in with zeros, I bring my decimal down so I know it's going to be in the right place. And then I simply subtract. 4 minus 0 is 4, 8 minus 5 is 3, and 4 minus 2 is 2. Well, 11 minus nothing is 11. So I end up with using 11.234 square feet that need to be covered with these tiles. Oh, step 3. Now I have to divide. But I can't divide by a decimal. I have to have a whole number on the outside. So that tells me I have to do my OOU. I have to go over on the outside to make it a whole number. And if however many times I move it on the outside, I have to do the same thing on the inside. So now I do my other over. Notice I've got a space there. I had to move it 4 times. There are only 3 digits. So I just simply fill in with a 0. Then I move it up and I hold that place value. Now I can divide. Whew. Seems like a lot of steps, right? Well, it is, but that is what math is about. So I'm going to say that 625 will go into 1,123 one time. And when I take and multiply those and I get 625, then I can subtract and I have 498 that's left. I bring down my 4. Well, how many times will 625 go into 4,984? I type in on my handy dandy calculator 4984 divided by 625, and I see that I get 7 and stuff. Well, I need to figure out what 7 times 625 is. I need to ignore the stuff. And 7 times 625 is 4,375. I subtract and I find that I have 609 left. Now I bring down my 0. I want to see how many times 625 will go into that. So 6090 divided by 625 gives me 9 and stuff. Ignore the stuff. So I take 9 times 625. That gives me 5,625, and I subtract them. When I subtract them, I get a remainder of 465. Now, I don't need to keep going and figuring out what this is going to be equal to. What I need to do is remember what I'm being asked. How many whole tiles will be needed in order to cover the blue area? Since there is a remainder, I'm simply going to say, well, I know I had to have 179, and there's some area going to be left over, so I need another one. So I'm just going to add another one, and that tells me that my answer has to be 180 tiles. That's a lot of steps to get to the answer, but that's what's required in mathematics. If I've showed it on my paper, I need to see it in your work. All right, so tonight's assignment, you have 6 different questions, 2 through 12 on the evens. Make sure you review this as many times as you need to. Watch it once you have the notes written down and truly listen to what I'm saying so you understand it. And then as you're doing your assignment, if you have questions, please ask.